So today we're going to look at equations of parabolas. And we're going to only look at parabolas when their vertex is at the center, which is 0, 0. So remember that we've talked about parabolas before when we looked at quadratic equations. It's like a U type of shape where it looks up or down. But this time we're going to look at all types of parabolas. And a parabola is a set of points in a plane equidistant from a given line, which is this one, that's called the directrix, and a point not on the line called a focus, so this distance here. So now when we're graphing parabolas, we need to find certain things. We're going to need to find the vertex, we're going to need to find the focus, we're going to have to find the directrix, and then we're going to have to find these points that are going to be parallel to that focus. And that's what we're going to be looking at. Remember, we're still talking about conics, so it's this slicing that's parallel here. Notice it's going to form this parabola. So we're going to look at 4 types of parabolas, which are going to be the ones that are looking up, either down, opening to the right, or opening to the left. So let's just make sure that we review what we've studied before. So remember that when we're talking about parabolas in the quadratic function, this is the vertex form where h and k were the vertex, and this was the standard form. Now what we're going to do is we're going to look at the new form. And again, we're only doing it at the origin, when the vertex is at the origin at 0, 0. So if you have the equation where it's x squared is equal to 4py, notice that the x is squared here. That is just like what we did before. If this p-value here is greater than 0, it's going to open up. Notice that the focus is always on the inside of that parabola, and then you have your directrix. And if the p-value is less than 0, then it's going to look down. Now, the new part is going to be when y squared is equal to 4px. Notice that the y is now being squared. So that's going to open either right or left. So if the p-value is positive, meaning greater than 0, it's going to open to the right. Notice that the focus is still on the inside of the parabola. The directrix now is going to be vertical, because it has to be parallel to the focus here. And if the p-value is less than 0, then it's going to open to the left. Now, we need to not only know if it opens up, down, right, or left, we also need to know what the focus is. So whenever we get an equation, this is the equation that we're going to look at. X squared is equal to 4py, or y squared is equal to 4px. And that's the form that we're going to be looking at now. So we're going to have to make sure that it's always in this form here. So once we have this, we're going to find out what p is. Once we know p, then all we're going to go is from 0 and move either up or down, or right or left of that p-value. And then if it opens up and down, that means the directrix has to be horizontal. And that would be y is equal to the opposite of p. If this opens right or left, then the directrix is going to be vertical. And again, this time the equation of a vertical line is x is equal to, and we're going to do the opposite of p. So we're going to keep that in mind every single time we do these problems. So let's make sure we identify all the information here. So the first thing we're going to do is we need to identify what p is. So notice this is a y squared. Because it's a y squared, that means it either opens to the right or to the left. Okay, so the first thing we're going to do is find out what p is to know if it's going to open right or left. Now notice this 4p is actually 16. So 4p is equal to 16, p is equal to 4. Since p is positive, this is going to open to the right. The vertex is still going to be at 0, 0. Now the focus, because it's opening to the right, The focus has to be on the inside. So think about it this way. It opens to the right. The focus has to be on the inside. So it's moving to the right of the vertex. So this is going to be 4, 0, because it's the p-value. The directrix, remember, it has to be parallel to that focus there. So it's going to be a vertical line. So it's going to be x is equal to the opposite of p, which is -4. Now the axis of symmetry, remember, it's through right here, the center of the parabola. So in this case, the axis of symmetry is going to be at the x value of your vertex here, which would be at 0. And I put y by accident. I apologize. It is y is equal to 0 because it has to be a horizontal line. That way, the top portion of the parabola can map with the bottom. So it's going to be a horizontal line, the axis of symmetry. Let's try the next one. Now, x squared is equal to 2y. This time it's x squared. That means it's either going to open up or down. So the first thing I'm going to do is I'm going to find out what p is. Now, this is what p is. So 4p is equal to 2. That means p is equal to 2 over 4, which is a half. Now, again, this one, because it's positive, it's going to open up, because this is either opening up or down. Now, the vertex is going to be at 0, 0. The focus, remember this one's going up, so the focus has to be on the inside. So it's moving up from the vertex. So this is going to be at 0, a half. The directrix has to be a horizontal line. So that means y is equal to the opposite of p. Now, the axis of symmetry has to be a vertical line. So this time it's going to be at x is equal to the vertex here, which would be at 0. So that would be here. So the axis of symmetry for this one is at x is equal to 8, while this one is at y is equal to k of your vertex. Your vertex, remember, here is h, k on this side. Good job. Okay, so now what we're going to do is we're going to graph some of these. So the rest you're going to have to do on your own, but we're going to graph a couple. Remember that your form always has to be in the correct format. So first thing we're going to do here is we're going to make sure that it's in the correct format. So we're going to divide. So this is going to be x squared is equal to -y. So first thing, x squared, that should trigger to say if it's an x squared, it's going to look up or down. So we're going to first find out what our p is. So 4p equals to -1 because it's a -1 here. So p is equal to -1/4. That means p value is negative. So that means it's going to go down. So it's going to look down here because the p-value is less than 0. The focus means that I'm moving down from the vertex, so this would be at 0, -1/4. The directrix is going to be horizontal, so this is going to be at y equals the opposite of p, which is 1/4. The axis of symmetry now is going to be at x equals to 0, because that would be my vertex. Okay, so I'm going to graph what I have right now. So I have 0, -1/4, which is right about here. That's my focus. My vertex is here. And then my directrix is going to be right about here. This is my directrix. Okay, now I do need to know that it is a U shape, so I do need to get other points. So what I'm going to do, you can plug in values for x and come up with them, or you can actually let, which is going to be what I would like you to do here, is get the points that are right next to the focus. So what we're going to do is, since we know the y value is -1/4, because that's your p-value, you're going to actually plug it in. So you're going to do x squared equals to negative, and you're going to put your y value, that p value for y, you're going to substitute in there. So you're going to put negative 1/4. So x squared is equal to 1/4, and x is equal to plus or minus 1/2 when you take the square root. So notice that when you graph it, it's going to be at 1/2, 1/4, negative 1/4, and then the other one, let me move the focus from here so I can graph the other one, right about here, and there's your parabola. So you do need to get those 2 points that are there right next to the focus. Is just plugging that y value, because it's a y value there, and plug it in. Let's do one more here. Let's do the next one. And it says x is equal to negative 8y. So the first thing we want to do is we want the y squared to be by itself, because we always want the quadratic term to be by itself. So we're going to divide here. So we get negative 1/8 x. So the first thing I'm going to do is I'm going to find out what p is. So here I'm going to go ahead and divide. So remember, you keep change flip, which would be negative 1/32. And that's what the p value is. So because it's negative and it's a y squared, that means it's going to open to the right or to the left. But because it's negative, it's going to open left. So it's going to open this way. The focus would be here, and the directrix would be this one. So the focus means you're moving from the center, and remember from our vertex, which is 0, 0, we're going to move left. So that means this would be negative 1/32, 0. And then from there, we need to get the directrix. Now the directrix is vertical, so that means x is equal to the opposite, which is 1/32. The axis of symmetry, now the axis of symmetry is going to be horizontal, so that would be y equals 0. So now we're going to graph the information that we have so far. So we have 0, 0. Now 1/32, negative 1/32 is really, really close to 0 here. So it's like at negative 0.03. So right about here, that's our focus. And our directrix is going to be right about here. Now we do need to make sure that we find the 2 points that are parallel to that focus. So notice here, it's the x value. I'm going to substitute this one for the x in here. So I'm going to do y squared is equal to negative 1/8 times 1/32, negative 1/32. So I'm going to go ahead and do y squared is equal to 1/8 times 32 is 256. And then, let me put the squared there. And then I'm going to take the square root of that, and we get y is equal to plus or minus 1/16. And when I divide 1/16, it's very close to 0 again. So it's going to be 0.06, so right about here, these are the points. And notice how it does open to the left, like we stated. So I do want you to try the other ones, and then you are going to go ahead and do the textbook problem.